Welcome to Mrs. Bibb's Algebra 2 class, week 2 for first 9 weeks. Please make sure to fill in your table of contents for the week. If you will also do your warm-up for the week, I've left you a few hints to help you and to remind you how to do these things. Please remember to do these on your own. Then, of course, you have your answers to check for the week. I have provided page 6 for you. It's in your folder. You can't see this says page 6, but over here across from the title, it says page 6. If you'll please read through the definitions. I did not put a definition for vertical shrink, although it's going to be the same as vertical stretch, except for this condition here. You're going to multiply by a positive factor, except that factor A is going to be a fraction, meaning it's going to be between 0, it has to be bigger than 0, and less than 1. So a vertical shrink is when you're going to multiply the y-coordinates by fraction. The next thing I'd like for you to do is I would like for you to match this column of parent functions with this column of related functions. Hopefully you pause the video to match these parent functions with the second column of related functions. Quickly, I want to go through what type of functions these are. You need to be able to recognize exactly which one of those 8 types of these functions that you have. Quadratic, absolute value, cubic, linear, exponential, rational, constant, square root. I would like to point out that the Smart Notebook software does not put that line across the top in a square root function. So anytime you see just that check mark, then I've used the square root symbol within the Smart Notebook software. You're welcome to add that line across the top to make it look proper. Okay, I have the answers beneath my sheets of paper here, so I want to show you the answers. The related functions. So as you can see, this has an exponent of 2, so does letter E. So those are both quadratic. As you can see from question 2, it has those vertical bars. That means you have absolute value. F also has those vertical bars. You have an exponent of 3 for number 3. And if you look at look at letter H, then there's also an exponent of 3. Number 4, f of x equals x. That's a linear function. The exponent is 1 on your x value. And if you look at letter G, the exponent is 1. Exponential, a base raised to an exponent of x. When you look at all of these choices over here, x is only an exponent for letter C. So that's why this is exponential. Number 6, my variable is in the denominator. And if you look at all of these choices, only choice A has a variable in the denominator. This is a constant function. There's no x here. And if you look at these here, the only one that has just a constant is letter D. Then for number 8, this is a square root function, so you'll see the square root symbol. And if you look at A through H here, letter B is the only one that has a square root symbol. So hopefully you connected those correctly. Now, before we look at this second column, we're going to, in a moment, match the transformations of the parent function to the related function. How were they transformed from here to here? And these will be our choices. But before we do that, I want us to look down here. Hopefully you can see it all. I think you can see the majority. If you have an up or down translation, up 4, down 4, up 7, down 7, then that number that you're transforming is on the outside. If you notice here, plus k is up k units, minus k is down k units. So I have a plus k for my linear, a plus k outside, and when I say outside, I mean away from the x. X is still alone inside the absolute value. X is still alone inside of the quadratic. X is still alone inside. Inside is when there's parentheses around your x or absolute value around your x. X is still alone in this exponent. X is still alone in the denominator here for this one. X is alone in the denominator. X is still alone under the square root. So when you have plus k or minus k is up k units, minus k is down k units. Let's look at a left or right translation. It's on the inside when it's a left or right transformation. And remember, up here I said that x is alone inside. Notice here. Now x is not alone, minus h is with it. If it's a minus h, then that's right h units. X is no longer alone inside the absolute value. It has a minus h with it. If it's a minus h, it's right h units. If it's a plus h, it's left h units. Same thing here. X is no longer alone with the square term inside. So in parentheses with it, you have a subtract h. So that's a right h units. Same thing here. Hopefully you see that pattern. Same thing here. Look at the denominator of this rational function. Same thing. And then we do need to fix this. Here, this one should be, the radical should go all the way across. And if you want to put parentheses around it, that's fine. But being under the radical is okay. Quickly, we'll go through the reflection. If it's a reflection across the x-axis, the negative sign is outside. It's not inside with it, it's outside. If it's a reflection across the y-axis, then the negative one is inside with the x, or in the denominator with the x, or under the square root like this one with the x. If it's a vertical stretch or shrink, then you're multiplying the outside by the number. A stretch is when a is greater than 1. A shrink is when a is between 0 and 1. If it's just 1, then that's the parent function. It's the same size as the parent function. And then a horizontal stretch or shrink is when a is greater than 1, or a is between 0 and 1 for stretch and shrink. It's on the inside. Horizontal is on the inside. And one big thing I forgot to type, so if you'll make sure to write it, is that you're going to do the reciprocal of the a value that you're given. So if it says to do a horizontal stretch of 5, then you would put 1/5 inside. So you're going to do the reciprocal. So again, horizontal stretch or shrink is inside, and whatever number you're given to do that with, you're going to do the reciprocal of it. Okay, so I'd like you to pause the video and go back up here and try to match A, B, C, and D with these functions, comparing, here's the related function, here's the parent function. Comparing these two, see if you can figure out if you're going up 4, down 4, left 4, or right 4. I have matched the related function with the description of its transformation, comparing the related function to the parent function. Hopefully you matched yours correctly. Make sure you used this information at the bottom. I promise you'll get the hang of it. Let's talk about the answers that I have. X is in the denominator. Plus 4 is not in the denominator with X. Plus 4 is considered to be outside from X. Outside, if you look down at the bottom, outside plus 4 is up k units. That's why I chose up 4. Looking at letter B, this square root function, plus 4 is inside the square root with x. Inside with x, if you have plus h, that's left h units, or minus h, that's right h units. You have plus 4, so that means left 4. Inside plus 4, left 4. Exponential function, x is alone in an exponent. The subtract 4 is outside or away from the x. So outside with minus 4 means down 4. This one is a little different, but let's compare the parent function. Here's the parent function. How do you go from a horizontal line on 2 to a horizontal line on 6? You go up 4. Letter E, minus 4 is inside with x, so inside with a minus 4 means right 4. So that's why I put D. Here's absolute value function. The absolute value is still alone inside. The plus 4 is outside. So plus 4 on the outside means up 4. This is a linear function. My x is alone inside. Minus 4 would be down 4. And the final one, this is a cubic function. Plus 4 inside with x means I have left 4. One thing that we've said in the past in my classroom is if it's on the outside, then it is what it is. If it's on the inside, that's a horizontal movement. That's a left or right movement. And it's the opposite of what we would normally think. When we look at plus 4, we think right 4. But since it's inside with x, then we do the opposite of right 4. It's left 4. Hopefully that little hint will help you. And just studying and knowing these little hints here, back of your paper, will help as well. I want you to go through and label what type of function 1 through 20, what type of function they are, quadratic, linear, absolute value, all those things. Then I want you to also come back and draw the parent function on every one of these graphs. These answers will be included in your packet information, but I want to show them to you quickly. So if you want to just look at the answers, on the first blank, I wrote which type, or type of function each of these were, 1 through 20. Then I highlighted in black the original graph, and then I graphed my parent function. You'll see I wrote parent function in pink on each of these. And remember, to graph the parent function, you're going to use that list of ordered pairs that I gave you from week 1 to plot them. See, you can see here I plotted -1, 1, 0, 0, 1, 1. So that's what you'll do for each of those, is plot the ordered pairs and draw your curves the best that you can for each of those parent functions. So here are the answers. Again, I'll just let you look at them quickly so you can see what they are. You do have a copy of it in your packet of materials for this week, but I want you to see them.